Well, hello students. We are getting ready to take our first test over our chemistry of reactions. And so I want to just take you through the book and show you some of the things that you will be asked to do on your next test. So let's get started. Okay, so let's turn in your books if you would, because this one's not going to have calculations on it. So we're going to go ahead and turn in your books to technically your definitions on page 9, which is physical and chemical properties and physical and chemical changes. But I'm going to take you to page 12. Okay, so page 12. Okay, page 12. And you're going to be given on this test some problems in which you have to identify whether it is a chemical or a physical property. Okay, so if you need to, go back through your definition on the previous page and read through that before you review this. Now, you should have the correct answers because we graded this in class. But you have the color of blue, which is just physical. You have density, which is physical. Now, flammability, if something catches flame, think about what we did in class. It definitely changed the substance, therefore that is a chemical. Solubility, if I dissolve salt in water and I evaporate the water, I'm going to get the salt back, so therefore that is physical. If we react it with an acid, you're going to get chemical. If it supports combustion, that means that when I react it with oxygen, I'm going to produce possibly an explosion or heat or light. Therefore, that would be chemical. That it tastes sour. Again, the way we do the sour taste is because somewhat it's reacting with our tongue, so that would be chemical. Okay, melting point. If I melt water, it's still water. That's physical. Now, if it reacts with water, that's totally different. That would be chemical. So anytime we use that word react, that's chemical. Hardness is physical. Boiling point, again, if I boil water, it just turns to water vapor, but the molecules are still H2O. The shine of it, again, is just physical. The odor, just the smell of something, not changing the smell, that's two different things, is just physical. And then again, when we talk about it reacting, that is chemical. Okay, so again, you're going to have a list of those, and you're going to have to be able to distinguish whether it is a physical or chemical property. Now, when we talk about physical or chemical changes on there, remember we have our list of evidence, and if you want to go to page 13, there is a list of the 6 things that you look at to determine whether or not it is chemical or physical. But basically, if it changes to something new, and you can tell, hey, this is not what I started with, then it is chemical. So again, dissolving is not chemical, it is physical, because I could evaporate and get back. Tarnishing, if you've ever seen something tarnish, it changes color. That's a color change going on there, therefore that is a chemical. You just cut an apple, well, it's still an apple. We didn't change that, so it's physical. Again, heat changing water to steam, it is still, the molecules are still water, they're just further apart. So that is physical. Baking soda reacting with vinegar, again, anything that reacts, we call it that, is chemical. Rusting, again, that is reacting, it's chemical. Evaporation, though, again, that is just physical. Melting is just physical. Now, milk sours, therefore it is changing from milk to, that grossy clabbered type stuff, therefore it's chemical. Sugar dissolving, that's just physical. Wood rotting, that is chemical. If you cook something, that is chemical. Tires being inflated, you're just taking the air molecules and spreading them out, therefore that is physical. Digestion, chemical. Ice cubes, it's just melting when you place it in the sun, therefore physical. 2 chemicals mixed together and you produce a gas, that is definitely chemical. Bicycle, changing colors, again, rusting, physical. Oops, sorry, my bad, chemical. I don't know what I'm thinking there. Again, you just crush something into a powder. It's still on the molecular level the same thing, therefore physical. Again, we're going to produce light or heat, therefore that is chemical. And again, melting is physical, but then it says reacts, so that is chemical. Okay, so you're going to be given a list of those, so be sure you feel comfortable with that. Okay, so if you will go on with me to page 22. Then we are going to do some translating. Definitely you're going to translate. Now, I can guarantee you will be given some of your diatomics. Okay? The other thing that I will be testing to see if you know what your symbols mean. So I'm probably going to give you some gases, some liquids, some solids, some aqueous, and maybe some crystals. Okay? So again, when we write this out, we say hydrogen, gas, okay, hydrogen gas, it reacts with oxygen gas to produce, that's kind of words we like, but you could say yields, okay, to produce, and you can say either dihydrogen monoxide, or if you're comfortable with saying water. Now, as long as you just say water. Okay, so my video messed up and cut off, so you didn't get to see some of it. But what I was saying here was, if you say water, we're going to assume it's a liquid. Now, if it's a gas, you would definitely need to say gas, or you could put the word liquid in there. This one's already written, but it is solid magnesium. So again, put it in that order, not magnesium solid, solid magnesium. So typically, except for gases, you put the state first. So solid magnesium, it's going to react with aqueous silver nitrate, use your yellow sheet if you need to produce, whoops, I completely left off of it, so we'll go here, aqueous magnesium nitrate and solid silver. Okay, and again, those could be switched around. So be sure that you know how to translate. Definitely something that you're going to be doing. Now, go to page 23, because then you're going to do the opposite. And this is probably the harder of the two. So, solid iron. So this is where you need to know your symbols. Solid iron reacts, means plus, oxygen, and again, remember oxygen, you've got to remember that it is O2, and remember all of our diatomics, our gases, technically except for bromine, bromine is a liquid, forms iron 3 oxide. So we have iron, we know it is a +3, oxygen is your oxide, it's a 2-. And again, if you're still struggling with this, this is from way back first semester, then that's a whole nother issue we might have. Again, you can crisscross your numbers, so this goes 2 and 3. And again, you really don't need those. And since they don't tell us, but I will on the test tell you whether that forms a solid or a liquid, in this case, it is going to form a solid. That's actually the lab we did with the steel wool. If you'll remember us taking that steel wool that was gray, and then we torched it, and it turned that blue color. So that is the reaction there. Nitric acid, I probably won't give you anything with a acid on there because I'm not going to expect for you at this point to memorize those. Now our next chapter is acids and bases, and at that point I will expect you to know your acids. But nitric acid is HNO3. It comes from nitrate, and then we put the H on it on there. It's going to react with lithium hydroxide. Again, go check your charges. Lithium is a +1. Hydroxide is a -1, so we don't need anything there. It does not tell us again here whether we've got solid, liquid, or gas on that, but just so you know, they both will be in aqueous form, just like what we did in the lab where we were taking those droplets, water bottle, or the bottles, and dropping on there. It will form lithium nitrate, LiNO3, and you would know whether or not that is a aqueous or a solid by, again, looking at your chart and seeing if it is soluble or insoluble. All nitrates are soluble, so that is going to be aqueous. Plus, and then it says liquid water, so we know it's H2O liquid. Okay? So again, those are the things you're going to have to be able to do. I'm going to tell you one, I should say two of the hardest that you'll have is remembering your O2. That's one thing. Balancing these, that'll be another. And then, guys, when you get this done and you react these, you're not done, because you are expected to go back in and balance these equations, where the ones over here on the other side on 22 were already balanced. So don't forget that. So I've got 3 oxygens and 2. So I need a 3 and a 2, which gives me 4 iron. Okay? And then I'm going to come in here and I'm going to do the same thing on there. And a lot of times when I see water, I rewrite it as HOH. I just think that is easier. So you've got an OH and an OH. You've got an L and an L. You've got an H and an H. And you've got an NO3 and an NO3. So this one is balanced all the time already. So remember, you must say balanced, or the other option is to go through and put 1. So you must do one or the other. So again, reminder on that. So you're going to get points, guys, when we come to do this on 1, is your compounds written correctly? 2, did you put your states of matter in there? 3, did you balance? So each one of those would be worth 3 points. So if you screw up, and you don't write that correctly, it's going to be kind of hard to do anything past that. Okay, so that is up to page 23, the things that you will be tested over.